Alcohols, phenols and ethers. Alcohols and phenols are formed by the replacement of one carbon atom from hydrocarbons. It may be aliphatic hydrocarbon or aromatic hydrocarbon. Let us see. CH3H, that is CH4, is methane. One of the hydrogen atom from methane get replaced by CH3OH group. This compound is alcohol. It's commonly called methanol or methyl alcohol. This is an aliphatic hydrocarbon, and when benzene ring possesses 6 carbon atom and 6 hydrogen atoms. When one of the hydrogen atom from benzene ring get replaced by OH group, it forms phenol. This is phenol, this is aromatic alcohol, and this is aliphatic alcohol. Next, how alcohols are classified. Let us start with alcohols, aliphatic alcohols. Alcohols and phenols are classified into monohydric, dihydric, trihydric alcohols according to the number of OH group present in them. Then listen, CH4 is methane. One of the hydrogen atom from CH4 get replaced by OH group. It becomes methyl alcohol. Methyl alcohol contains only one OH group. So this is a monohydric alcohol. This is aliphatic monohydric alcohol. If in the case of ethane having 2 carbon atoms, one hydrogen atom from each carbon atom get replaced by OH, it becomes dihydric, because in this case 2 OH groups are present, so this compound comes under dihydric alcohols. And third one is trihydric. In the case of propane, if each carbon atom possesses one OH group, it comes under trihydric alcohol. So this is about aliphatic alcohol. It's classified into monohydric, dihydric, trihydric according to the number of OH group. Next is about benzene ring. If hydrogen from benzene ring get replaced by only one OH group, it is called monohydric. If 2 hydrogen atoms from benzene ring get replaced by OH group called dihydric, that dihydric compound possesses 2 OH group, and if 3 hydrogen get replaced by OH group called trihydric. Let us see some example. This is monohydric, that is simple phenol. It is monohydric. There is only one OH group in aromatic compound benzene. Then here, if 2 hydrogen atom get replaced by 2 OH group called dihydric, if 3 hydrogen atoms get replaced by 3 OH group called trihydrics. So this is according to the classification based on monohydric, dihydric and trihydric, that is according to the number of OH group. Next, compounds containing sp3OH bond. First of all, it's again classified into 3, that is primary, secondary and tertiary compounds. Here in this case CH3OH, the alcoholic group, that is OH group, is attached to the carbon atom. Which carbon atom is in sp3 hybridization? Which is in sp3 hybridization, there is only single bond between this carbon and 3 hydrogen atoms and 1 oxygen. The next compound CH3CH2OH. Here also the first carbon atom to which OH group is attached, that is the first carbon atom having only one carbon neighbor, and this first carbon atom is in sp3 hybridization. This carbon atom is in sp3 hybridization. Next one, this compound comes under primary compound, primary section. This is primary compound. The normal ethanol is a primary compound because the first carbon atom possesses only one carbon neighbor, and at the same time this first carbon atom is in sp3 hybridization. And the second one is secondary, that is CH3OH. Here this is the first carbon atom. you can see the first carbon atom possesses two carbon neighbors, and at the same time this carbon is in sp3 hybridization. So such compounds comes under secondary compounds, secondary. And the tertiary, the third one is tertiary, that is CH3, C, CH3, CH3, OH. In this case, you can see this is the first carbon atom. This carbon atom possesses three other carbon neighbors, and this carbon is in sp3 hybridization. This is the first classification based on C-sp3-OH bond, that is primary, secondary and tertiary. Primary means which having only one, first carbon atom possesses only one carbon neighbor and which is in sp3 hybridization, and the second one, secondary, in the case of secondary carbon atom, first carbon atom possesses two carbon neighbors, and this first carbon atom is also in sp3 hybridization, and here there is three carbon neighbors for the first carbon atom and which undergoes sp3 hybridization. Next compound containing carbon sp3-OH bond is called allylic compounds. Allylic compounds having, let us see one example, CH2 double bond, CH single bond, CH2 OH. Here, this is the first carbon atom. This is the first carbon atom and this is the second carbon atom. Here, the first carbon atom is in sp3 hybridization, but the second carbon atom possesses one double bond that comes under sp2 hybridization. Such compounds are called allylic compounds. Allylic compounds having double bond, but the first carbon atom possesses only single bond that comes under sp3, and the second carbon atom possesses double bond. Such compounds are commonly called allylic compounds. Next is benzylic alcohols. This is benzylic alcohols. Why? Because this OH group is attached to this CH2 bond, CH bond, carbon atom, but next to this carbon atom one aromatic ring. Aromatic, you know, aromatic having partial double bond nature. Aromatic compounds possess alternate double bond. So here also the first carbon atom is in sp3 hybridization, but the second one is in sp2 hybridization. But here the second one is a part of an aromatic ring. So this type of compounds, alcohols, are commonly called benzylic alcohols. They are called benzylic alcohols. Compounds containing sp2 carbon OH group. This first carbon is in sp2 hybridization. Such compounds are called vinylic group. Vinylic alcohols. Vinylic alcohols having one OH group which is attached to the sp2 hybridized carbon atom. Here the first carbon atom itself having double bond, that is vinylic compound. This comes under vinylic group. So here you can see the first carbon atom is this carbon atom which is in sp2 hybridization. This type of compounds are called vinylic compounds. This type of alcohol is vinylic alcohol. One more example, CH3, CH double bond, CH OH. Here also the first carbon atom having one double bond, so this comes under sp2 hybridization, and this also comes under sp2 hybridization. They are the examples of vinylic alcohols. Ethers are of two types, symmetrical ether and unsymmetrical ether. This common formula of ether is R, O, R or R dash. Here you can see two alkyl group in the either side of oxygen. If two similar groups are present in the either side of oxygen, it comes under symmetrical ether. That is, for example, CH3O, CH3. Here you can see two methyl group present in the either side of oxygen atom. So this compound is a symmetrical ether. Next compound, C2H5O C2H5. This group is also possess two ethyl group in the two same group present in the either side of oxygen atom. Next is unsymmetrical carbon. Example CH3O C2H5. Here you can see one methyl group and another ethyl group present in the either side of oxygen atom. So this is unsymmetrical ether. This comes under unsymmetrical ether. So ethers are classified into two, symmetrical and unsymmetrical. If two similar groups are present in the either side of oxygen atoms, called symmetrical ethers, and this is unsymmetrical ether. Next, how will you name such compounds? Here, this is methoxymethane. Methane, this is the parent here, and oxymethane is the common name for ethers, and methoxymethane is the IUPAC name of this compound. And this is ethoxyethane. Ethoxyethane. Eth means because this was one side of the oxygen atom possesses one ethyl group. This is eth, and the parent is ethyl here with oxygen atom. Then this about unsymmetrical ethers. This is named as methoxyethane. Another compound having C2H5 and CH3 group from the in the either side of oxygen atom. This is also called methoxyethane. These two compounds are same. Let us check some IUPAC names of some compounds, some alcohols. The first one is CH3OH. This CH3OH is methanol. Its IUPAC name is methanol. And here, because there is only one carbon atom and one OH group is attached to that first carbon atom. And the second one having three carbon atoms. Three carbon atoms having one OH group present in them. So this is propane, and in the first position there is OH group. So this compound is called propan-1-ol. Called propan-1-ol. The next compound also possesses three carbon atoms, but in the second position you can see one OH group. Hydrogen atom from the second carbon atom. One of the hydrogen atoms from the second carbon atom get replaced by one OH group. So this compound is propan-2-ol. This is propan-2-ol. Next compound is butane. From the second carbon atom of butane, one of the hydrogen atom get replaced by one OH group. One of the hydrogen atoms from the second carbon atom of this compound get replaced by one OH group. So we can put number from here, and the second carbon atom you can see one OH group. The compound is, the parent's name of the parent is propane, butane, and second carbon atom having one OH group. This compound is butan-2-ol. Then the last one. You can see three carbon atoms, and each carbon atom possesses one OH group, and this compound actually comes under trihydric alcohol, and the parent is propane with three OH group in each carbon atom. So 1, 2, 3. First carbon atom possesses one OH, second carbon atom also possesses one OH, third also possesses one OH. So this is propane 1, 2, 3 triol. Propane 1, 2, 3 triol. So these are about alcohols, aliphatic alcohol. The first one is methanol, second propan-1-ol, second propan-2-ol, third one butan-2-ol, and the last one is propane 1, 2, 3 triol. IUPAC names of some phenols. Here this is phenol. One of the hydrogen atom from benzene ring get replaced by one OH group is called phenol. This is phenol, and if phenol consists of one CH3 group, this is called 2-methyl phenol, because the first carbon atom possesses one OH group and the second possesses one CH3 group, that is methyl group. So this compound is 2-methyl phenol. And here you can see in the third position from here, this is the first carbon, second carbon and third carbon. The third carbon possesses one CH3 group. So this compound is 3-methyl phenol. This is 3-methyl phenol. And here the last compound, this compound having OH group in the first carbon atom and the second carbon atom, third, fourth carbon atom possesses one methyl group. So this compound is 4-methyl phenol. Then here about some dihedric alcohols. Here you can see two OH group attached in the ortho position, 1 and 2 position. You can see two OH groups. This compound is benzene 1,2-diol. In the first carbon atom there is one OH group and the second carbon atom also having one OH group. So this compound is benzene 1,2-diol. Here the first and third carbon atom possess OH groups. So this compound is benzene 1,3-diol. And here in the last compound, in the first carbon atom and in the fourth carbon atom, you can see two OH groups. So this is benzene 1,4-diol. Benzene 1,4-diol. So this is about the naming of some phenols. Methods of preparation of alcohols. The first one from alkenes. You know, alkenes having double bond between carbon atoms. Here by acid catalyst hydration you can prepare alcohol. There are two types of alcohol, symmetrical alcohol and unsymmetrical alcohol. Addition of water taken place in the different step. Here in the presence of an acid only, catalyzed hydration taken place with alkenes, we get alcohol. Let us see, CH2 double bond CH2. This is ethene. On adding water in the presence of an acid, you will get, actually the formula is CH2 double bond CH2. You know, water having two ions, one H plus ion and OH minus ion. By adding we get, see, double bond get break, double bond gets break and we get OH group. OH group get attached to the one carbon atom and the other carbon atom, hydrogen atom gets attached. So this is in the case of alkene, that is symmetrical alkene. But in the case of unsymmetrical alkene, you know, you have to follow Markovnikov's rule. Markovnikov's rule states that the negatively charged adentum, here OH group is negatively charged adentum goes towards carbon atom having lesser number of hydrogen, and the anti-Markovnikov's rule states that negatively charged adentum goes towards carbon atom having large number of hydrogen in the case of either side of double bond. Here in the case of unsymmetrical only, here let us see about Markovnikov's rule. CH2 double bond CH single bond CH3. This is an unsymmetrical alkane. If hydration taken place, what happen? Here actually negatively charged atom is OH minus. It goes towards here and the hydrogen here. So we get CH3 single bond CH OH CH3. Thus we can convert alkene, that is, this is propene to propane 1-ol, propene to propane 1-ol. So this is these all preparation from the alkenes only. Second method by hydroboration oxidation. Propene when reacted with the diborane in the presence of hydrogen peroxide, we get a compound which possesses one BH2 group, which again react with the propene, same propene. One of the hydrogen also get replaced by this alkene and we get this compound which possesses BH group. Then again when it react with propene, the same alkene, we get this compound possesses three number of alkyl group with boron. This boron does not possess any hydrogen atom. Then when it reacts with water in the presence of H2O2, we get alcohol and boron trihydroxide. Boron trihydroxide, and we get this alcohol called propanol. So this is another method of preparation by hydroboration oxidation. Next preparation from carbonyl compounds. Carbonyl compounds means carbon possesses one double bond. Carbon double bond O. This is carbonyl compounds. These two are carbonyl compounds. One is aldehyde, CHO group, and the other one is ketone, possesses CO group. Here, by reduction of aldehydes and ketones, we will get alcohol. Reduction taken place in the presence of a catalyst. Addition of hydrogen is called reduction, which is taken place only in the presence of a catalyst such as palladium or nickel, sodium borohydrate or lithium aluminum hydrate or also can be used as a reducing agent here. Here, by adding hydrogen in the presence of nickel or palladium, we get what happened? This gets break and we get RCH OH. Two hydrogen atom gets into the one hydrogen atom goes towards one oxygen and one towards here. Thus we get alcohol. Actually this is a primary alcohol. And here in the case of ketone, if the same reaction taken place in the presence of any catalyst, will get RCH. This is secondary alcohol. We get secondary alcohol. From aldehyde, by reduction from aldehyde, we get primary alcohol. From ketone, we get secondary alcohol.